Hello, welcome to the next webinar on what's new in version 2024. This time it will be a review of new features and improvements to the design modules of advanced design. My name is Mateusz Budziński. I'm a product line manager for structural software in Gretec, and I will have the pleasure to briefly present the improvements of this version. This is a quick summary slide. These are the points of my presentation, which means I will try to present a few selected new features in each design module. I will start with some novelties common to many modules. The still ratio in the info panel. What does it mean? As you know, one of the basic results regarding the reinforcement of concrete elements is the reinforcement still ratio. The value is now visible immediately after the calculation in the bottom right part of the info panel, so you can check it quickly. For multi-span beams, the corresponding still ratio value is presented in the header, separately for each span. The next point, as we know, one of the ways to speed up the work is to use the project templates with predefined settings. Previously, project templates could be selected when starting new standalone project or before opening an element in advanced design. Now, additionally, it's possible to apply a project template to element that is already opened. For example, having opened a foundation for design after importing it from advanced design, you can use a new command to apply a template to import from this template, for example, just predefined solid layers. Next point is really small, but common to all drawings on design modules. Now when adding custom annotation on drawings, it means any text command on any place of drawings. Now it's possible to enter the text with multiple lines just by using the enter keys. Now we switch to the first module, RCB module. One of the options for advanced design for reinforcement concrete beams that are supporting concrete slabs is the ability to consider such beams as ribs. Thanks to this, during the design analysis of this beam on advanced design, the beam is considered as T-section, and the design efforts are not just the forces acting only in the rectangular beam part, but from the entire monolithic T-section. With new version, when a rib beam is exported from advanced design to RCB module, instead of rectangular beam section, the equivalent monolithic T-section is imported. Also, we import the equivalent integrated design internal forces, and not only pure finite element forces. Next improvement to beam is about supports. The column supports can be now located not only from the bottom, but also from the upper side of the beam. This column location is now also imported from advanced design model. Thanks to this, we get better quality of drawings, as we can see the real position of columns. The next change is similar to the previous one. Now it's possible to define as a support another beam, perpendicular beam that acts as a support. This data can be edited manually, so we can define, okay, this is a perpendicular beam that's acting as a support. But also this data can be imported from advanced design. Again, this also has influence on drawings, because on drawings you can see that kind of supports. And the next point is also related to perpendicular beams, but this time to smaller ones. Now we can define such perpendicular beams that have a lower height than the main beam and are not treated as a support. Such smaller beams are now also recognized when importing from advanced design model. Thanks to this, we have better drawings as we can see the position of that perpendicular additional beams. And the last point for beams, we can display now diagrams with values of reinforcement areas calculated for torsion. There are separately two diagrams, one for longitudinal and one for transversal reinforcement from torsion. Next module, RC column. In the column geometry definition window, we can now define not only the height, but also the width and the length of upper beams. This information is now also imported from the advanced design model. This beam geometry data is now automatically transferred to the window for automatic determination of column buckling lengths, if the auto method is selected. If the auto method for the column buckling length is selected, then moments of inertia and beam lengths are filled automatically to this special dial. The next is a very small but often requested improvement. One performed by default check is the verification of columns resistance with using interaction curves. It's a very helpful verification, but it's not mandatory in most standard regulations. So this small improvement is just a possibility to deactivate this check for columns. Next point is for editing bars. Now we can select the method of distribution of transverse bars on columns. We can define the distribution using the quantity or quantity on length, spacing or spacing on length. In fact, this helps a lot when defining bars, as when defining distribution on a table, depending on the selected option, all other parameters of this distribution are automatically calculated. So this makes the definition and addition of that transversal bars process much easier. Now is the time for the foundation module. I will start with a small point. When we have defined a multi-layer soil and we activated the verification of bearing capacity using the substitute foundation method, then the shape and the dimensions of such a substitute foundation are now presented in the view. So it's easier to check results of this method. The next point is also for giving more info about results. This time about cracking on the footing path according to your code. First, just after the calculations, on the info panel, we can see the most important information from the crack verification. And second, on the report, there is a new table with details about the crack width check, and both improvements makes that it's easier to check results of this verification. The next new option is also related to cracking. Now it's possible to keep the cracking in the limit by automatic increasing the reinforcement. There is a special new option for that, and when activated, in case the crack width is bigger than the limit, an additional reinforcement is added to decrease the crack width. This is useful in cases when it's more beneficial to keep smaller footing thickness with more reinforcement than just increasing the thickness. Yes, the next module is a concrete wall module. First improvement is related to drawings. When we generate drawings for walls, by default, a rebar schedule is generated. But if there are reinforcement meshes, reinforcement fabrics, then we have two options. Either, as before, the schedule for meshes can be separately generated and added to the drawings, or we can use new drawing style that allow automatic generation of schedules for bars and fabrics. So both schedules are generated at once then. The next point is for shear walls. For shear walls, it's now possible to import and export resultant forces using an Excel sheet. For this, there are two new icons available in the window of load definitions. One is for import, one is for export. We can import resultant forces per wall or per group of walls. Of course, this is helpful, especially when load data we have is available from external sources, or when we just want to easily modify values using some formulas on Excel. Now it's time for the SLAB module. I will start with quite extensive change, new bar shapes. We expanded the list of types of rebar shapes for concrete. In fact, with two types, with U-shaped bars and also double-bended bars. Thanks to this, there are 4 anchoring methods available, with straight bars, with hooks, with double bend bars, and with using U-shaped bars. For managing this, there's a special tab on settings where we can define different settings for anchoring for the first and for the second layer of reinforcement, separately for free edges and for edges on the supports. Of course, new shapes of bars are easily visible on the drawing, so as you see on the picture on the right bottom side of the slide. And continuing the bar anchoring topic, in the latest version, the window for editing generated reinforcement has been expanded to allow editing anchorage parameters. Separately for each reinforcement zone, we can decide now how we want to consider the anchorage. We can set the details like diameters, cover values. We can also modify the length of hooks. So in fact, we have more options to manage anchoring on each zone. For the automatic definition of reinforcement, one of the main settings is how to cover the theoretical reinforcement area using one or more layers. On a new version, we can specify the coverage method not only by the percentage, but also by absolute values of the reinforcement area. For example, for the bottom reinforcement in the X direction, we want that the first layer of the reinforcement should have minimum 6.5 square centimeters. The first layer means the reinforcement that is covering the entire slab. And if there are some areas where we need more reinforcement, more than 6.5 square centimeters, and additional bars will be added locally as the second layer. So with this, we can easily manage the amount of reinforcement covered by the first layer. But as we know, not only automatic methods are available for slabs. Sometimes it's better to define reinforcement zones manually. Until now, zones were defined by entering a closed polyline, point by point. Now we have also 2 additional methods, defining a rectangular zone by 2 points and a rectangular zone by the center line and offsets. Such new methods are much faster and easier to use, so defining zones graphically is now much easier. Now we switch to improvements to drawings for slabs. First, we can generate drawings separately for each reinforcement direction. So we can generate, for example, the drawing for the top reinforcement with bars only for X and only for Y direction, as you can see on the screen. Of course, as it was possible earlier, we can also generate drawings with bars in both directions. Next improvement to drawings is related to bar annotations. We improved the algorithm for automatic placement of descriptions to avoid overlapping with and collisions with bars. Of course, if we have many bars or bigger scale of the drawing, location of annotation never will be perfect. That's why annotations can be moved manually. And to help this, from this version, we can also easily change positions of parts of the bar description. So we can separately move the bar mark and the dimension line. We can also disable part of the description above the dimension line. So shortly, in this version, we have more possibilities to adapt drawings without using CAD systems. Another improvement to drawings is related to how we display openings. Now openings are displayed with using special symbol, kind of shadowing, as you can see in our picture. Yes, it's a small improvement, but makes drawings more clear. There is also an option to disable showing this symbol, but I believe drawings with such symbol looks better. Another new small option to drawings is for deciding if structural grids should be visible on drawings or not. It's useful when on advanced design we have structural grids defined on a model, but after opening a slab in the RC slab module, we don't want to see such access on drawings for a slab. Of course, it's just an option. Yes, we finished with concrete modules, and now just a few words about the masonry wall module. The first improvement is intended to make it easier to view defined loads. So now it's possible to show graphically external loads, like loads on the top of wall, as on the left picture. Of course, this will be helpful when defining the data directly on the masonry wall module. And we can also display now resultant internal forces from vertical design sections, as on the right picture. Even there are separate and dedicated diagrams for such integrated forces. Now you can see easily such design values on top, on the middle, and the bottom of each calculation panel. The next point is a small improvement. When displaying the results in the form of stresses diagrams, now it's possible to select the position of the horizontal section used for stresses, if it's a bottom, if it's a middle or top of the wall. And the last point to masonry walls. Now, masonry databases are separated from the data of the current project. Using other words, we need to import data from database to a project, and we are not using directly data from libraries. Why this change was done? To avoid mistakes. First, we can now modify in each project the data of the manufacturer, for example, ceramic blocks, without affecting the database. And in an opposite way, when we change some data on database, this change will not affect previous projects if we reopen such in the future. And the last module for today, the steel connection module. In fact, there is only one, but very big novelty on this release, on this module, is a new category of connections, a welded truss connection. That connections allows for multiple geometric configurations where the main beam can be square or rectangular tubular section, or can be steel cross sections. Diagonals can be square or rectangular tubular cross sections, and we can define them in different configurations. We can use 1 or 2 or 3 diagonals, which allows modeling the most typical common for Eurocode 3 configurations for diagonals like K-type, KT-type, N-type, T-type, X-type, and Y-type, as you see on the screen. As it's with all other connections, new connections can be modeled directly on the steel connection module, or on the standalone module, but can be imported from advanced design model. So when we define the connections on advanced design model, and we opened for verification on advanced design. Then all the data related to geometry, flow profiles, materials, and also internal forces are imported automatically to the module. The analysis include all required verification according to Eurocode 3, including weld verifications. On the info panel, you can see the summary results with the basic info. But for more details, we can just open the reports and see all the data on the detailed report with all the formulas and data. That's all. But I have one slide more just as a reminder. This year, we have the next edition of the Advanced Design Award. It's an open contest. When GREATEC awards projects that were designed with using advanced design. There are several benefits of taking part in this competition. All info you can find on the dedicated website. You can find the link to this website on the GREATEC website. I'm sure you can also just Google to find it. And I think it's really worth to take part on this competition. That's all. Thank you for watching and have a nice day. Bye.